Hi guys, welcome to the notes video for lesson 6.2. This lesson is on recursive formulas. We're going to have two lessons on recursive formulas, so this is our first one. A formula for a sequence is a way of describing the sequence. So it's a compact thing I can give you, and you can look at it and you can say, okay, here's the sequence. We're going to learn two different types of formulas. The first is a recursive and the second is an explicit. So today we're focusing on the recursive. What is a recursive formula? So a recursive formula is a formula for a sequence that consists of two parts. So consists of one, the starting term of the sequence, so the first term of the sequence, and two, a rule for finding the next term, using previous terms. So recursive formulas tell you where the sequence starts, and then they tell you how to get the next term. And you can see that if you have both of those pieces of information, then you can get the whole sequence just going term by term by term. You start where the formula tells you to start, and then you use the rule to get the next term, use the rule to get the next term after that, the term after that, the term after that. So it's a way that you can generate the sequence. All right, we're going to learn a formal way with some math symbols to write recursive formulas, but sometimes it can be a little overwhelming to try to just get your mind around what a recursive formula is and the symbols at the same time. So we're going to start with kind of a bridge between those things with now-next formulas. So now-next formulas are informal recursive formulas. Or I should say, it's an informal way to write recursive formulas. Oh my god, I can't spell the word recursive. There we go. So this is not the end goal. Think of it as just like a bridge between where we are right now, having not written recursive formulas before, and the ultimate goal of us writing recursive formulas with the math symbols. So this is like an intermediate step towards where we're going. Okay, so we're going to be doing two things with these formulas. The first is going from a formula to a sequence. So if I give you the formula, generate the sequence that it's describing. So let's practice that or see what that looks like. Here's a now-next formula. So we see that in this formula, we're given where the sequence starts. So this is the first term. And we just say that's where it starts. And then this part of the rule or formula is our rule for finding the next. So we've got the two parts that we described above, our first term and our rule. Okay, so how do I go from this formula to the sequence? Well, the first thing is we can just list the first term right away. So we know that the sequence starts at 40. Okay, now let's try to interpret this rule. This rule says the next term is the now term, or the current term, take away 6. So this is saying to get the next, subtract 6. Okay, so I'm at 40. To get the next term, I need to subtract 6. So my next term would be 34. or 40 minus 6, right? Then the rule says again, to get the next term, subtract 6. So my next term is going to be 34 minus 6, which is 28. Subtract 6 again, I get 22, and so on. So each time we're subtracting 6. Okay, so we started with our formula, we got the sequence. Now let's try starting with the sequence and writing a formula. Okay, so let's say we start with this sequence here, 2, 6, 18, 54, 162, and we want to write a now next recursive formula for it. So we know that the first part of our formula has to be the starting value, or the first term of the sequence. And we see right here that the first term is 2. So we just say start equals 2. Okay, now we need our rule for the next term. So I need some way, some description of how to get the next term. So let's look at what we've got going on in our sequence. To get from 2 to 6, you could add 4 or you could multiply by 3. Those are two options. So 2 to 6 plus 4 times 3, let's look at 6 to 18. I could add 12 or I could multiply by 3 again. So the adding wasn't the same, but the multiplying was. Those were both times 3. Let's check. So we could do 18 times 3, you could check that, and it is indeed 54. And 54 times 3 is 162. So we've got times 3 every time. So our rule is basically going to say, to get the next, we want to multiply the current by 3. Okay, so how would we say that over here? There's a couple ways we could say it. We could say to get the next, you take the now term or the current term and you multiply it by 3. Or you could write it this way, which says the same thing, 3 times the now term. I don't know if you guys hear Ollie, but he's meowing at me. Okay, so that's it. That's sequence to formula. We started by just writing down the start value, and then we figured out what the rule was, and then we wrote that in our now next form. Okay, so if you think you got it, you can go right on to the check for understanding. Otherwise, there's another video that goes through a couple more examples of using the formulas to generate sequences and also starting with the sequence and then writing the formula.